We covered a lot of space news this week in our daily 60-second videos. Just in case you missed them, here's an edited summary video of all the stories from the week. Please like and share the videos if you enjoy them, and have a great weekend. Since Comet Shoemaker-Levy 9 slammed into Jupiter in 1994, there's been huge interest in whether we could protect Earth from a similar impact. On Friday, ESA announced that it will go ahead with a mission to rendezvous with the 375-meter-wide asteroid 99942 Apophis. The asteroid will pass harmlessly, but very close to Earth in 2029, and the Rapid Apophis Mission for Space Safety, or RAMESSES, will accompany it through this close pass. RAMESSES will measure how the asteroid is stretched and squeezed by the intense gravitational forces it will feel from its close flyby. These effects could include landslides that expose new material from below the surface, and of course any changes to the orbit of the asteroid will also be measured. This will tell us a lot about the internal composition of asteroids and how they're affected by external forces, all of which could help us figure out the best way to deflect an asteroid that may be on a collision course with Earth. Don't panic, currently know of no asteroids on a direct collision course with Earth, but RAMESSES is also intended to show that we can rapidly deploy a mission to an asteroid if needed. As most of you know, the Sun has been super active as we head towards the maximum of solar activity, and on July the 21st we had several M-class solar flares and a large coronal mass ejection. This cloud of magnetized plasma is headed towards Earth and is predicted to arrive sometime later on Wednesday. The resulting geomagnetic storm could give beautiful aurora displays as far south as New York. It's notoriously hard to predict the exact arrival time and whether aurora will be seen, but keep looking up and you never know what you'll see. The data for this incredible image of Jupiter was captured by NASA's Juno spacecraft as it passed about 29,000 kilometers above the planet on May the 12th. Citizen scientist Gary Eason then took the raw data from JunoCam and processed it into the amazing image you see here. Juno data is freely available to the public, so go grab some data for yourself and make your own images of Jupiter. Links to the data and NASA's citizen science programs are in the description. Astronomers using JWST have directly imaged a cold super-Jupiter planet around another star for the first time. The planet, 6 times the mass of Jupiter, orbits its star in the triple star system Epsilon Indi about 12 light-years from Earth. The planet Epsilon Indi AB has a 200-year-long highly elliptical orbit with surface temperatures on the planet around 0 Celsius. Planets like this are very hard to detect using the two main methods for exoplanet searches. First, the transit method, where the planet passes in front of the star, dimming its light and allowing us to detect it. The second method is to detect the gravitational wobble that the planet induces in its star, but for a planet in such a wide orbit, this can be very difficult. Scientists directly image the system using special features of JWST's Miri instrument to block the light from the star, allowing them to see the planet, although they didn't find it exactly where they expected due to inaccuracies in previous observations. Despite this, the team are confident they've directly detected the planet, and there's a great press release over at the Max Planck Institute's website. Scientists using historical data from NASA's Messenger spacecraft to study Mercury think the planet may have a layer of diamonds 10 miles thick beneath its crust. Mercury has always puzzled astronomers with its dark surface containing patches of graphite and its very dense core. Astronomers think Mercury may have had carbon-rich magma oceans in its early history, and by combining the Messenger observations with lab experiments on Earth to simulate the high temperature and pressure on Mercury, they've been able to gain new insights into the structure of the planet. There's a great article describing the research at space.com, and the paper is published in the journal Nature Communications. NASA is celebrating 25 years of the Chandra X-ray Observatory in orbit, and over at their website you can see 25 beautiful images from Chandra. There are some truly incredible images, many combining Chandra data with observations at other wavelengths to help highlight the place of the X-ray universe in astronomy and the amazing work Chandra has done over the last 25 years. The Perseverance rover has detected hints of ancient life on Mars in an arrow-shaped rock nicknamed Chava Falls. Perseverance has studied the rock and detected organic compounds, a wispy vein of calcium sulfate running through the rock, and a bunch of small splotches surrounded by black rings containing iron and phosphate. These findings suggest water once flowed through this area, which makes sense given that the rock sits on the edge of Narepa Vallis, a suspected ancient river valley. The water may have carried mud full of organic compounds into the valley that over time was captured as the rocks formed, and subsequent exposure to water created the calcium sulfate deposits and the ringed spots. On Earth, these ringed spots are often the result of microbial chemical reactions. The team have exhausted all of the analytic tools on board Perseverance, so the only way to definitively figure out what's going on in the rock is to get it to a lab on Earth for further testing. With the uncertainty over the Mars sample return mission, it's not clear if or when that will ever happen. Still, this is an exciting discovery and advances our knowledge of the history of this region of Mars. That's